Thank you very much. Thank you for inviting me to speak in this conference, and thank you for attending. Um, so, the agenda for my presentation would be to basically talk a little bit about what Greenbyte is and the way we see the future electrical systems changing and how they might look like in the future. And then finally, talk about what is digital transformation and why are so many industries talking about digital transformation. How does that impact? How does it look like when it comes to renewable energy sector? And in the end, I will talk a little bit about what is the role of a data scientist and data in enabling this digital transition. So Greenbyte is a software provider. We provide software for renewable energy assets like wind and solar. We are based in Sweden. We have about more than 24 gigawatts of renewable energy connected to our system today, about 8,000 plus turbines. We are experts in software, and surprisingly, we are one of the very few companies who has an in-house data science team. So the way we think that it's going to happen in the future, if we look at this plot, we see that we are in 2020. Still, the conventional energy is dominating when it comes to electricity production, but we see that there is, hopefully, there is going to be an exponential growth in the coming few years. So if we look at the energy market today, more or less wind turbines and solar are excluded from being reliable because the grid is not really so much dependent on these kind of systems today. But it's not going to be true in the future. So that's going to be one of the biggest challenges for these kind of intermittent sources. But if we look at the electrical system in itself, and I would like to refer to what Omid talked about, the tree structure, and to the previous presentation with the virtual power plant, actually, in my opinion, it's not going to look like a tree anymore in the future. We have a lot of renewable energy assets distributed, utilities. There is fragmentation in the market, so there are very small players contributing energy. So that means that utilities are not the only big companies monopolizing this area. There is a lot of data. There are a lot of assets, much more generators than there are today. So there is going to be a lot more data. So consumer data coming from the assets, and using this data to derive insights will be a key competitive advantage going further. So when we talk about renewable energy, where are we today in terms of digital transformation? So if we look at the pyramid, we first need to digitize. That means that you need to start collecting the data, making it available, accessible, and trustable. I feel that this part is quite well taken care of, both in terms of solar and wind. More so in wind, solar is still catching up, but it's not bad. Once you have this, then what you would want to do is to save some money. So you want to optimize your processes, make it more efficient. So you would want to automate the processes that you are doing. For example, let's say reporting every month how much you have produced. So digitalization would be to save money by doing something small. And finally, when you are carried on with when you have finished the digitalization, you know how your data looks like, you know how you can utilize it. You would want to create business models which are data driven and eventually earn more money from that. In my opinion, what people are talking about today in terms of in the renewable energy sector is more about digitalization. And the next step would be digital transformation. So when we started working on using data science for renewable energy, we had to understand what is the requirement. Why would someone want to use AI or ML or things like this? So we had to find a problem. So we looked into our own data set, and what we realized was, I'm sorry, I don't know why you cannot see this, but basically the pink one is an average of all different turbines, and what you see here is the availability in terms of percentage. What it says is that on an average, so the median availability for a turbine is around 98%, but the average is 95. What this means is that there are a few turbines which are performing bad, and it's bringing down the entire portfolio down. So the question was, so if you put it in monetary values, if you can improve the performance of these low performing assets, what you can make is 48 million euros every year. So this is for a portfolio of 6,600 turbines, you will be making 48 million euros more by bringing up the availability of these low performing assets. That's about 3,200 euros per megawatt per year. So how do we do this? One of the things that has always been a problem and has been talked about a lot is the maintenance. And in wind, in 2019, it costed about 15 billion euros, out of which 8.2 billion euros was because of unplanned maintenance. That means that if we can reduce the cost of unplanned maintenance, then maybe we can improve the availability and we can catch or capture some of this lost revenue. So we developed a tool called Predict. Basically, what it does is that it uses the data from the turbines to estimate the condition of certain components inside the turbine. And when we started developing this, what we realized was that the model does not need to be very complicated. It is a very simplistic artificial neural network model, which runs quite well. It provides very good output. It's quite accurate. Then we started to think of how can we give a bit more information about what action should be taken given a certain alert. So what we built is around the models, a system wherein we use our customers to label the data. So it is an ongoing model which trains every time certain faults are taken care of. And in future, we will be able to give better recommendations. A case study example is a case like this, where we were able to detect fault in the main bearing. So there was a turbine where the main bearing had to be replaced. I'm showing this because this was a very special case where the customer was able to save about 100,000 euros because they identified the fault within the warranty period, and eventually the OEM had to pay for this replacement. Well, if it was not within the warranty period, what they could have done was to save some kind of downtime, because they could have planned the maintenance better. And so the availability would have gone up. So this is one case where you can look at the turbines, the assets as an individual. But since we have collected a lot of data, a lot of turbines connected to our system, what we could also do is to look at the system as a whole. So here is an example where these turbines, they create events. They create events that are recorded. So what you could do is take the entire portfolio, group all similar type of turbines together, and just simply plot the number of hours each event takes per turbine per year, right? So this is for the entire portfolio. Now you want to see how your portfolio is doing, or you want to identify outliers. So you can plot that on the x-axis, the same thing on the x-axis, and eventually what you will see is that there are some statuses or some events that take much longer for your assets than they do for the entire portfolio. And this means that there's something wrong in your portfolio. This is not really data science, but it is still useful information. And this you can do when you have collected and collated the data properly. So as data scientists, we really get excited when we start working on new things. We create a model, we get insights, and everything works well within the test environment, and we are happy. This is what happened to us. So I'm just sharing my experiences. So when we were at that stage, when we thought that we had a very good model, we put it to work on thousands of turbines at the same time. And then we realized that at each step, there is a point that would fail. So sensors would give wrong measurements. There is missing documentation, so we don't really know what we are measuring. There are communication issues, and especially in turbines, you don't have data for 3 days, and then the data is backfilled. So how do you run the models that run every day on this backfill data? And finally, of course, we will introduce some bugs in our own code. So how do we manage these things? So as a data scientist, what I've realized is that just having insights, getting insights from the data is not enough. What you really need to do is to foresee what kind of problems you're going to have when you apply these models on a large scale. That is not an easy task. Probably the only way to do it is to learn from experience. But maybe if we share this experience with others, then not everyone does not have to reinvent the wheel. So yeah, this is something that I would really recommend all the people working in data science to think about. Now, I've talked about all this, and this is AI and energy. So I wanted to share a study where, MIT, I got this from MIT Sloan Management Review. What they did was they went to people in different industries and they asked the question, how much do you think AI will impact your work in the next 5 years? And we can see that technology and media, telecom are probably the most optimistic because they are already being impacted. For example, Netflix, Facebook, Google, we all know that they are using AI. I was really surprised to see energy the second worst. I mean, it's almost similar to public sector. It's very disappointing. So the question to me was, why is this so? And then my background is as an electrical engineer, and I used to work in oil and gas, so I can understand the problem here. In energy, we come from a background where we say that if it's not broken, don't fix it. So there is some kind of an inertia where we don't want to change the processes that we think work. So as a data scientist, what do we need to do? We get the data, we build a model, we get the insights. Unfortunately, this is not enough, especially when it comes to renewable energy sector. We need to build trustability in our models. We need to work on making people trust this. We need to integrate it with the workflows. We don't want people to change because we have created a model or some insight. We need to integrate it in their workflow. There will always be a decision maker, at least for now. And that decision maker will initiate an action. And only when an action is initiated, we will see the value. And only when people see the value, will there be more investment when it comes to data science in the renewable energy sector. So with that, I thank you. And yeah, that was my last slide. Thank you.